Hello, this is James Tismanakis. I have set my working directory for this final project and then actually have gone in and did the install for all the different packages, and then I've gone in and created the library for each package, and then went in and set the seed so we can work there. And the seed, we're trying to eliminate the NAs of the data. There's quite a bit of NA in the data. So I tried to actually remove the code myself using multiple formats to eliminate the NAs, but I ended up losing my data. It wiped out the entire database a couple different times, and then I actually read later that what it said to do basically does wipe out your database. So I converted it back to the original format, and right here I changed the bots attack S22, which was our homework, and ended up naming it as we did in class, the parent S22 V1. So you can tell my environment's huge for the amount of coding and the amount of trying to get some of the programs to work. So did all that. We actually added ID numbers for C1 instead of the blank students, and then we went in and ran code trying to change things. So I actually took this code and ran this code creating the IDs. Actually missed some of it here, and then ran the parent code, and then ran the missing percentages, which just does change the data from the NAs to 100%, where I was not able to eliminate the data. It does change the data and takes it to 100% in all the NA categories. And then actually created a data frame to determine the variables of high level of missing to know what's useful and what's not useful. So I ran this data point, and then actually came in, I keep missing that little piece, and then came in and ran missing variables. And then you're getting into the point where we wanted to run 0 1s to separate which is which, and it appears to be working this particular time. I actually had to start this 3 times to get those categories to actually run. And then we separated the bots from the verified data, so it'd make it a whole lot easier to run the data. And I actually picked the locations of what I wanted to run, so I was looking at number of times that they visited the camp. I was looking at the age of the person at the camp, and I was looking at how it brought their ability to interact at the camp much better. So that's the 79 through 82. That really kind of interests me to see how they improved or how age affects their interaction. So ran that category, and then we ran it with the verified, which is really much more important because it's the actual people that we know were at the camp. And then down here, looking at excluding the C1, which is the identity in it. So we kind of ran it 2 different ways, taking out the C1 category or the identity, and then I looked at running the actual programs for all the ones I had, and I looked at adding demographics to the program to see how I could get demographics explained. And then we had data not included from, I had 7 variables. I took it down to 6 to run. Again, those are the pieces that I found important for this particular project. and then form multiple imputations from the mice packages, and then also set the method to PMM predictive mean matching. Ran that program, and then use the third input data set. 3, as in the class, basically works the best from professor's time period. So I ran that data, and then added the ID numbers back in. In one of the particular formats, you had the C1 removed. When we added the new section, the C1 was added back in, but it was actually added back in at the end of our data. And then we wanted to go in and look at verifying the data and verifying the responses. So that piece of data was run. And then we looked at basically the data that we were changing into. We mic'd the data to get better information. And we're actually running here the summary of it. And then added the ID numbers back into completion bot set. So then we got into the mean and covariance of the data using the Mahalanobis. Not sure how to actually say that, even though we've used that quite a few times in class. So ran this particular piece of data. Then we worked with the thresholds for the outliers, adjusted parameters and the variables with the outliers, using the common significance of 0.05, which is common in everything that we do. Identified the outliers, and then identified the bots and their outliers. And then after we ran the pieces, we had 352 that are bots but not outliers, and 13 bots with outliers. Actually ran this piece of data to work with that. And then excluding the C1 again, which is an ID number for the outliers. During we processing the bots, we made sure to train all the columns. All that data was run. Some of this is too big to actually fit into the screen. So we have an error down here. But it actually ran the first time I was working with it. Some of these are actually in our environment. Identified the outliers, and then had the verified number with their outliers. And the verified number drops down considerably. When we first started the program, we were at 607, then we dropped down to 365. Then verifying it, that brought it down to 208, and then we start segmenting as we go into what we're specifically wanting to look at. So we have the data for which is what I'm actually looking at, which is the number of times, the age, and then the individual pieces of how did they do and how did they interact with going to the camps. In this one, as we came smaller in honing on the data, we got 190 that are bots, no outliers, and 18 bots that are outliers, and that number dropped compared to the 352 and 13 down to 190 and 18. And we created a new data frame excluding the outliers, and then we ended up running a calculation, correlation, and p-value. And then we did the correlation with the bots, and then we ran a p-value matrix. We do these two as we're going. And then we looked at the data all being 0, and then we ran the p-value to match. And then we actually wrote a program to where it would take it from our script to actually on our desktop, and that's where I set the desktop originally, to go any file saved to the desktop actually into my file on the desktop. And then we went into verifying responders, ran that program, and then we had 0 correlations found when we ran this program. And in the correlation matrix verified, we actually had 0 on the bots, but we actually had information to look at on each of my categories on how they were correlating to each other. So that was quite interesting to see. I mean, if you notice, each one were 13 and C13, and C20 and C20, each were correlated at 1 since they're actually the same concept. Then we ran the p-value matrix from the verified numbers. I missed the R. And then we actually wrote both of those to go to the desktop, or our file on the desktop for each. And the data verified shows the correlations where the bot showing 0 correlation, where a strong correlation was found in C87 to C91, where around 0.7 to 0.8, which is a strong correlation. Then we ran Fisher transformation. And had inbots to go to from inbots 365 to the verified to 190. I actually got the whole thing in there. Yep, okay. And then we wanted to find out the z-scores for the differences. So we actually have a couple of different programs. I just noticed it keeps populating my environment and what I'm running. And then you go in here and go all the way down to the bottom. Missed one again of the code. Jeez. All right, get everything in there. Too far. I gotta figure out where in the world I was. Okay, way too far down. Too far down. Let's get up here. There we go. And we ran that program. And here we actually can get the p-values. So this is where we're actually doing our own kind of calculations based on what particular pieces of information that I wanted. Again, I was really looking at how the age affects and how the number of times that the camp affects, and how you're more, I'm calling it more outgoingness and more involved and more communicative to it, and actually wrote that to our desktop. And in doing the p-values and p-scores, and actually can make just made screenshots of that to use in the data for the write-ups. And I had to go back in and make sure that the psych package was loaded to do the alpha. So this took a phenomenal amount of time to get everything to run, but I was able to end up running the alpha. Yes, find actually where the one that worked. I left some of the tries in to make sure of running, to show the alpha. Let's see. And then ran this data of the selected parts I work with from the main database. And I wanted to find out the gender, but really I just every time I'd run this, it pretty much came to 1. So I mean, I can try actually running this to show. And I ran this multiple different equations. I love when it proves me wrong. 426, 140, and 2. And then I was trying to calculate the mean and standard deviation. And I actually was able to capture this much better at the end of the program, finding other packages to do. One, the skewness and kurtosis, so I actually went in and Googled a program, a package I had to install. So I installed both of these packages and library to run the skewness and kurtosis based on the original programs I wanted to use, and then the added programs with the demographics, and then calculated it. And each time I ran the skewness and kurtosis for each of my segments, it dropped us into NA. And the same thing was done for kurtosis, generating, let's run the whole package. Oh, wow. Kurtosis, the kurtosis value actually worked for the first time. I'm going to go in and do a screenshot of this to save to my desktop so I can actually work with this. One of the problems I've had running this thing is it's taken me 3 to 4 times to get the software to actually run, and this just earlier this afternoon did not run, but now must have been missing a piece of the equation, but now this time it actually ran, which I'm very excited about. And then I was wanting to find the mean and standard deviation. So I actually ran several different calculations to actually locate that, and I kept running into errors. So then I continued on. These are where I looked at doing the gender. You'll find towards the end that I actually have the mean and so when I did the gender from number 39, I come to 1. So I know there's an issue that's not just 1, not everyone are male or females. And again, I tried another scenario to find genders. And I was actually looking at a different database, because we have multiple databases that we have created to find genders. And here I got into another program looking at mean and standard deviation correlation for my main Pacific pieces. So I actually ran each of those and then ran the table, which actually gave me mean values from the verified. Then I ran the code for standard deviation, which is actually on the main variables I was looking at. And then part of the deal, we wanted the Pearson's correlation, and I did it based on the main parameters that I was working with. And then when I actually print the code out, I was able to find that in the database, and I actually screenshot that to use in the write-up. And then at the very end of all the data, actually wrote a copy to have the CSV of the completed data, which is this version right here that I used to run my main pieces of data. So this was the broken out scenario that most of my data came from. But as you can see, ran quite a few different scenarios, and you can even see where I tried to eliminate the NAs and actually eliminated the entire database, and actually did that on 2 different times. So learned my lesson on some of the codes that I was using. So that is the conclusion of the actual R script running all the pieces, and then this piece will then go into all the pieces that I have screenshotted and saved to the desktop as a CSV file that will be used to do the actual data the actual data write-up for this paper. Thank you very much.